Let's talk about watts, how hard the system works, how voltage and current team up, to make sound, signals, and switching, and how that teamwork decides the load on every circuit. You'll run into speakers tapped for 1/4, 1/2, or 1 watt, and relay coils marked something like 0.36 watt at 24 volts DC. What's really going on behind those numbers? Watts measure real work, not just energy. Power tells how much real work the circuit is doing. Watts quantify what volts and amps are doing together. More watts equals more work per second equals more system load and more heat. Now we're back at the formula wheel. Watts tie voltage and current together. P for power or watts. So watts equals volts times amps, or amps equals watts divided by volts. We call this the power formula. Watts connect what the amplifier delivers, what the speaker handles, and what the relay coil draws. Speakers and amplifiers. Watts in the audio circuit. Each speaker's tap, 1/4, 1/2, 1 watt, etc., adds to the total load on the amplifier. The amplifier's rating, for example, 50 watt at 25 volts, is its maximum rated output. 25 and 70 volt systems use transformer taps to distribute power safely. Always total the speaker watts. Don't exceed the amplifier's capacity. Size the amplifier in watts. Measure the circuit in volts and amps. Relay coils. When the coil is rated in watts. Some relays list coil power in watts instead of amps. Convert it. Amps equals watts divided by volts. Example, 0.36 watt at 24 volt equals 15 milliamps, or 0.015 amps. Use that math to verify your driver or control module rating so you don't overheat or damage an addressable relay or something else. If it's marked in watts, don't guess, convert it. One overheated relay can ruin your day. End-of-line resistors. Small parts, real power. Every end-of-line resistor gives off a little heat. That's why it has a watt rating. The manufacturer's installation sheet, not the drawings that you may be using on the job site, specifies the value and wattage. The resistor that ships with the panel or module normally is the tested and approved part. If the prints don't say, check the book or the installation manual. The right wattage is written there, not guessed in the field. When replacing or reusing end-of-line resistors, if the original is lost or broken, match the ohms and meet or exceed the watt rating. Underrated resistors can drift, overheat, or open up and cause intermittent troubles. For example, a 10,000 ohm quarter watt end-of-line resistor might survive just fine on a zone input, but a power limited output, such as a speaker circuit, could require half watt or more. Some voice circuits and amplifiers specifically call for 1 watt parts. Always verify the specification before installing. Higher wattage is safer when the specification allows it. And I've got a quick reference table. I won't go through this whole chart for right now. You can review that later if you choose so. Other places you'll see watts. Power supplies and amplifiers. Output rated in watts. Battery standby. Amp hours times volts equals watt hours. We don't use watt hours very often in the fire alarm trade, but you may see that at some point. Power limited circuits, UL and NFPA limits in watts or VA. VA is another way of saying watts. It's volts times amps. End-of-line resistors match wattage for the heat. Relay coils, solenoids, door holders, often rated in watts, convert to amps if you need to do a calculation. Cabinet and enclosure heaters are rare, but they're watt rated for steady loads. Watts show up anywhere the system does real work. Sound, heat, or motion. Know what they mean and you will never overload a circuit. Voltage pushes, current flows. Watts tells you how hard the system is working. Keep the push steady, keep the load honest.